Welcome back to another amp dyno video. I had Sasha's cardio amplifiers on my bench for a check and they are in nice condition except the power 250 M2, which was idling at more than 3 amps. So I checked the capacitors, I applied new thermal compound, there was also a problem with a bad solder connection, and finally I readjusted the idle current to just under 2 amps. After that I decided to dyno the Punch 250 M2 and the results were impressive. Let's go and check this guy out on the dyno.
The amplifier is connected to the dummy load. I start with 8 ohms mono, that means I test both channels driven into a 4 ohm load. Continuous power test, 1 kHz.
Check out the voltage of the amplifier, the supply voltage. It's directly connected to the amp's terminals. Get into clipping. We got 78 volts.
The Punch 250 M2 delivers 195 watts into a 4 ohm load per channel, both channels driven. And the next continuous power test with 50 Hz.
I got a peak voltage of 76.8 volts.
187.8 watts into a 4 ohm load per channel, both channels driven.
With a continuous input signal of 1 kHz. Get into clipping, I reduce a little. That's 41.3 amps.
The Power 250 M2 has an efficiency of 68.8%. First test is 1 millisecond and then we have 81.6 volts. That's around 213.4 watts into a 4 ohm load, just around 20 watts more. I think it's useless to make 20 milliseconds and 8 milliseconds dynamic power test. A 4 ohm mono load is connected to the amplifier. That means I'm going to test the output power into a 2 ohm load per channel, both channels driven. And I start as always with 1 kHz continuous power test.
Clip free, 13.66 volts.
I got a peak voltage of, so I calculate with 73.8 volts, 698.4 watts, mono 4 ohms, 349.2 watts into a 2 ohm load per channel, both channels driven. Into 2 ohms the amplifier has an efficiency of 67.2%. Continuous power test, 2 ohms per channel, 50 Hz.
So I got a peak voltage of
71.4 volts, 326.8 watts into a 2 ohm load per channel, both channels driven. Dynamic power test, 1 kHz, 20 cycles, and I catch one burst.
And I always check the last cycle. If the last cycle has clip, it's not valid in my opinion. Check out if it's going into clipping. Still no clipping. There we have it. I would take this peak voltage here. We have 74.4 volts. Then I check all the cycles at the same voltage level. That's valid. 74.4 volts.
We have a small amount of dynamic headroom. Instead of 349.2 watts, we have 354.9 watts. That's 709.8 watts. Dynamically 1 kHz, 20 cycles. This value is comparable to the value you will find in your old school Rockford Fosgate burst sheets. 8 cycles every 32 milliseconds. Another standard. Now I go to the last cycle, of course, check if it's going into clipping it. There we have it.
I reduce. Do we get more than 74.4 volts? Yes, we have 75 volts.
With 8 cycles we have a slightly higher value. Now we have 360.6 watts into a 2 ohm load per channel, both channels driven.
And now I check if we get some higher values with just one cycle. I increase input signal, that's clipping. Let's take this for example. And we got 78 volts.
We got 390 watts into a 2 ohm load for just 1 millisecond. And now a 2 ohm load is connected to the amplifier. Continuous power test 1 kilohertz into a 1 ohm load per channel.
So we don't get output power into a 2 ohm load.
This amplifier is not my amplifier. That means I'm just testing a 1 millisecond burst test.
I catch the burst, have it here, try to increase a little more. We get into clipping, I go back. And I take this peak voltage,
73.2 volts. In this case we have around 670 watts into a 1 ohm load per channel, both channels driven, but just for 1 millisecond.
Thank you very much for watching, and thanks to all supporters. I wish a Merry Christmas and a Happy New Year. See you next time. Bye bye.